Hey. Welcome, Lambda School mini bootcamp attendees. If you're here, this is week 3 that we've held this mini bootcamp session. Really glad to have you along with us today. My name is Ryan Allred, and I am a data science instructor here at Lambda School. I'm really excited to have you along today because if you were here the last 2 weeks, we've been working in JavaScript and building some web applications. Today, we're going to be doing something a little bit different in that we are going to be using Python to fit and deploy a machine learning model, right? I want to give you an introduction to data science. What is it really all about? I want you to understand how is it that we train machine learning models and then be able to build a simple one here today, right? And get it someplace where it's useful, where other people can take advantage of the quality of that algorithm, right? So I'm super excited to be here with you today. Before we really jump in, I need to call your attention to a couple of housekeeping items, all right? First off, if you want to follow along with everything that we do today, which, by the way, I 100% encourage, that's going to be one of the best ways to learn some of the things we're going to be demonstrating today, you're going to need a couple of different accounts. First thing is you're going to need a Google account. You maybe already have one if you have a Gmail account or a Google Drive. That is your Google account, but if you don't have anything Google related at all, you may need to get a Google account. That's the most important thing today. All right. Now, towards the end of our discussion, we're going to be taking our machine learning model and deploying it to the web. And if you want to participate in that portion of our discussion, you're also going to need a GitHub account and then later on a Netlify account. So go and make the GitHub account first if you don't have one already. And then when we use Netlify, we will log in with GitHub, and that will help us make a connection between our GitHub and Netlify accounts. All right. So those are probably the most important first steps I can guide you with. And this document you're seeing right here on the screen in front of me is also accessible in the YouTube description. It is what we call a Colab Notebook. And it's a place where we can write Python code and execute it and see what happens as we write that Python code, right? So go ahead and click on the link to this Colab Notebook in the video description. It's going to be the best way for you to follow along with me, all right? Now, when you click that link, you'll see my notebook here, but you will not have the ability to make changes to the notebook, all right? This is why you need your Google account, because I want you to make a copy of this notebook to your Google account, and that personal copy will be yours to edit and modify as you're following along with me. All right. So the way that you're going to do that is in the top left corner, once you have my file opened here, again, look for the colab.research.google.com link in the video description, say File, and then save a copy in Drive. Okay. And it'll open up a new tab here, and it will take what was previously my version and say copy of first ML model. That's the title of this document here. And then you should be able to edit this document as much as you wish. All right. So make your own copy. I strongly encourage you to follow along with us here. Another thing I'll point out is that this document should update as I'm working in it. All right. So as I write Python code, you should be able to see it if you visit the link in the video description. So if you fall behind at any point, you can visit that link in the video description and see the code that I've already written and copy and paste over into your notebook as necessary. Since we don't have as direct communication with you, I'm not going to be able to help with as many small bug fixes today. So next best thing is being able to compare your code to mine directly by visiting that link. All right. That being said, when you visit my link here, my version of the notebook, and if you don't see all the code that I've written, you may just need to refresh the page. Sometimes giving a little refresh will help it load and catch back up with where we're at. All right. Also, in the video description, we have a link to an application here called Slido. Slido is where you can add questions, and I will be pausing at, try to pause at even increments through our discussion here to take some of your questions. Anything that I can't get to during our discussion, we'll do some Q&A towards the end. All right. So please let me know any questions you have as we're talking about these topics, and I'll try and be concise in answering them, which is a challenge for me, but I'll work on it hard today. All right. Now, if you attended the last couple of weeks, you probably saw that our discussion was around an hour. Today, I expect it to go a little bit longer than that, maybe an hour and 20 minutes, hour and a half. So just so you're mentally prepared, we'll try and take a short break in the middle of that, so you're not, locked into hearing me blab for an hour and a half straight. But this is a little bit more complicated of a topic, and I'm trying to cover a lot in what we're talking about here, because I want to give you the big picture, and I want it to be exciting. All right. So hopefully you've made those accounts while I've been talking, and you've made a copy of this file to your Google Drive, and you're ready to go, ready to follow along with me. All right. Today's learning objectives. What do I want you to get out of this? I want you to be able to explain how important it is that the data science work we do create value for others. If nothing else, I really want that to sink in with you, that's what data science is all about. It's not about machine learning algorithms. It's not about fancy tools or writing code. It's about generating value with data, given the work that we do. All right. Also, I want to introduce you to a methodology for kind of managing data science projects called CRISP-DM. We'll talk about what that means, and I want you to be able to see what really goes into doing data science work. It's not just, using neural networks and fancy tools. There's a lot of work that happens in addition to, the machine learning that we do. And last but not least, I want to actually fit a machine learning model with you here today. We're going to be creating a model called a decision tree classifier, and we'll be using it to classify penguin species based on some attributes of those penguins: their beak size, their flipper length, what island they're found on, etc. Right? And that's what we're going to be trying to accomplish with our machine learning task and our classifier here. Okay. So as this is the very first data science mini bootcamp we've had, I want to start from the top, take a step back and say, what is data science? All right. You can Google this. You'll see tons of definitions. I've given my own definition here, Ryan's definition of data science, right? Data science is the practice of working with data to do interesting and valuable things. Okay. And now you might say to yourself, that's kind of vague. Well, data science itself is a little bit vague. All right. But the emphasis I want to point out here is that data science is not about using a particular set of tools. It's not about solving a specific kind of problem necessarily. It's about creating value, right? And I want to emphasize that if you are interested in getting a job as a data scientist, you're going to be working at a company, and that company's going to expect you to be creating value for the company, right? At least more than what they're paying you. Probably at a minimum 2 to 3 times more value than what they're paying you, right? So they're investing in you. They want to get a return on you as an employee, right? So, right, if you want to make that, that 6-figure salary, you've got to learn techniques and tools that will allow you to generate, at least 2 to 3 times that in value. And that, when you think about it in those terms, it's like, whoa, do I know enough to generate that kind of value? Well, don't worry. You don't need to generate all that value with your code and the math and the things we do in data science. You can generate that code mentoring a teammate, helping push a project forward, in all kinds of interpersonal ways and with soft skills as well, right? So we don't need to only do this with our data, but we do need to do that with the sum of all of our efforts as data scientists, all right? Also, I put some dollar signs here, but I want to emphasize that the value that you create doesn't necessarily need to be able to be quantified in terms of dollars, right? It may not show up in the company's bottom line directly, but you need to be making a strong contribution and be, pulling your weight in your role. All right. So that being said, how can we generate value from data, right? Well, I would argue that many data science tasks fit into one of these 4 categories. They're either going to help us better understand something about the world, something about our business, something about ourselves, or make decisions based on that improved understanding, right? You'll hear this a lot, that, data science is about getting actionable insights to, improve decision making, right? Common terms that explain data science. I would also agree that sometimes data science results in increased efficiency and cost savings. Along those same lines is things like automation, right? And when you think of automation, you probably think of self-driving cars, right? And I don't know, factories and robots and things like this. Whereas robots is not quite as involved in data science as the media would have us believe in movies you've seen around Terminator or Age of Ultron or whatever it may be. Still, there's it has a role to play there. And then last but not least, data can generate value in terms of accurate predictions, right? Can I take some data that I have and be able to learn how to predict something, right? So can I take data about homes that have sold in my area and use it to predict the price of those homes? In a way, I could automate the process of appraising a home if I get really good at generating those predictions, right? So any data science task usually falls under one, if not more, of these 4 categories here. Now, down here below, I have a longer bulleted list from a great post here on the website, InnoArchitect, okay? And it goes into a little bit more specifics about some of the particular categories of data science tasks that are out there, along with some specific examples. Things like facial recognition on your phone to unlock it, Siri and Alexa, Amazon recommendations, Spotify recommendations, Netflix recommendations, dashboards, FICO scores, sales and revenue forecasts. All these things are data science related and create value because they do one of the 4 things above. All right. So first learning objective, data science is about creating value. It's not about using specific tools or techniques. It's about making an impact and making a contribution. So you're probably asking yourself, well, if it's not about the tools, then what should I learn, right? What should I do first? Well, I would say that the data science community at large has kind of come to an informal consensus about what tools seem to be the most impactful. So what should you start learning first? Well, one of the great ways to explore this question is to look at job listings and see what they're asking for. Skill with Python is asked for in over 75% of data science job listings. The next most requested skill is experience with SQL, the database querying language. All right, it's asked for in over 50% of data science job listings. So if you only did 2 things, it would, in my opinion, if you learned Python and SQL really well, you'd be well on your way to being a contributing data scientist. All right. Now, all the machine learning, all the statistics, all the math, and those other techniques, that is going to be kind of like the hot sauce on top of that foundation of Python and SQL ice cream. All right. So if you're here today wondering how do I get started with data science, brush up on your Python and say to yourself, okay, once I've got some familiarity with Python, how can I use it to do something interesting, to do something valuable with regards to data? And I want to really show you an example of that today. That's my end goal, is to introduce you to some Python tools we can use to do something interesting. All right. Great question here. I am new to Python and programming. Am I going to be lost through this course? I don't think you'll be lost, because I want you to just follow along with me, and I'm going to try and explain everything that I do. All right. Now, there may be some syntax that is new to you, okay? But I hope that over doing these things multiple times, the code will be somewhat self-explanatory, and you'll be able to understand what you're doing, even if you don't have the syntax memorized, right? We only have an hour and a half here today. My goal is not that you be able to do from memory the things we're talking about today. But I hope you'll be able to follow along and understand what we're doing. My goal for today is we're not necessarily going to start from square one with Python. Okay? So if you don't have any Python experience, you just do your best to understand, okay, we've written this line of code, what is it doing? Not so much on the square brackets and periods and quotation marks and other pieces of syntax here. And this second question, I'll leave it here for the end a little bit more, since it's a little more broad and general in terms of question about Lambda School. Okay. So a learning objective number 2 I talked about is I want to introduce you to a methodology for approaching data science projects called CRISP-DM. CRISP-DM. This is an acronym of sorts that stands for the cross-industry process for data mining. Okay. Now, data mining is a little bit of an older term. You'll hear, data science be talked about much more commonly nowadays. So maybe nowadays we would call this CRISP DS, right? The cross-industry process for data science, but it works well in both domains here, right? So what CRISP DM is all about is a series of steps that we can take to generate value from data, right? We start with business understanding, or a problem that we want to solve, something that's relevant to our business. We try and really understand, what's going to move the needle here, what metrics are important, what have we already tried in this area. We try and assess the situation, determine our goals, etc. This is maybe the most important step, but it's also the step that's the hardest for me to train you on, because this business understanding section is unique to wherever it is you're going to work, and it's going to change from project to project. All right? And in fact, a lot of the things in a data science project will change from project to project. Okay, there's a fair amount of just variation in what's needed in order to generate that value from the data. Okay, once we have a good idea about what our goal is, well, then we're going to try and collect data, right? Whether that's querying it from a database, sending out surveys, running experiments, getting data from some online repository of public data, something like that. We've got to get that data in one place, and we got to see, is that data of good quality, etc. Right? Next, we'll move to data preparation. We're going to try and clean up that data, make sure it's ready to be used. And then the machine learning step is really just this modeling step. All right, that's where we're going to take the model and fit it so that it can be smart, right? And make solid or accurate predictions. All right. Then, once we've trained the model, we have to evaluate it. We say, okay, is this model actually helping with our business goals, our business understanding? And last but not least, we will deploy the model somewhere where it can be used and useful, and we can really get full value from it. All right. So, one word of caution here. This may seem like a good linear process. You start here on the left-hand side, you end up at deployment, and everyone's happy. Well, that is somewhat true. At any step in this process, you could run into a roadblock and have to go back to a previous step. Okay? Maybe you get all the way to model evaluation and you learn, oh no, my model didn't perform very well. Maybe that was because the data that I fed it was not very good, right? We have a saying, garbage in, garbage out. If you don't give your model good data, you're not going to get good results. So maybe you get all the way to model evaluation and you find yourself having to go back to data understanding and data preparation. Very common thing to have to kind of iteratively cycle through this process in order to build up a system or a project that ends up creating real value for companies. Okay, so don't think it's not just purely linear. We may be, jumping back and climbing our way back up through this kind of timeline, so to speak. Right. My goal for today is to do a little bit of a speed run through the CRISP DM framework here, the CRISP DM methodology. Right now, in a true business scenario at a job, it may take days, weeks, even months to get through this process and to get a really good solution that's providing great value. All right, we're going to do it in an hour, 45 minutes. All right, so hold on to your seat. I'm going to try and explain the code I write as best as possible, but my goal today is not necessarily every single piece of syntax from the code, and I don't want you to stress out about that either. My goal is, can you catch the vision for what data science is all about? And can you see what we're trying to do and how we're going to kind of extract value from this data? All right. Okay. That being said, what are we going to do? What's our business problem, right? We're going to start with business understanding. Well, maybe a little bit odd of a scenario, but we are going to fit a machine learning model to classify penguins. Okay. Imagine you are a scientist here at the Palmer Long-Term Ecological Research Study Area in West Antarctica, right? And your job is to study this habitat and ensure its health, right? Be able to know, okay, what things can we do to promote the health of of Antarctica and the animals that live here, etc. And one day you're specifically tasked oh, I'm getting a message from Maureen that I may need to change the share permissions here. It says anyone on the internet with this link can view. Okay, so anyone should be able to access this. I'm going to reshare this link with Maureen, and she'll, if it differs from the one that's in the description, she will update it. My apologies there, but I think the permissions should be correct now, if they weren't before. So, all right. Okay, back to what we're talking about. We're scientists. We're interested in Antarctic wildlife, and we have a particular project to study some penguin species. Some of them are, dropping in their populations, becoming more endangered, things like that. And we want to understand, okay, what makes these penguins tick? All right. Oh, Maureen tells me she's updated that link. So if you're having trouble accessing this file or making a copy of it, please revisit that Colab link. You're lucky that we haven't started writing any code yet, so you're not really behind in terms of following along quite yet. All right. So this is the actual Palmer station. Cool thing here, on their site, they have like a webcam. Okay. If you click that link in the notebook, see if this can load. The live stream is taking up some of my internet bandwidth, so it's taking a minute here. If it ever loads, on the top right here is the webcam. You can actually see the conditions right now at the Palmer station. And it looks like it's struggling for me. We'll come back to this, right? Every time I come and I look at the webcam, I say, I hope I can see a penguin, right? Because, obviously there's penguins here, right? So take a look at that. It's pretty cool. One thing I want to point out is that this Palmer station is on what we call the Antarctic Peninsula. And it's kind of on the west side of it here. This peninsula stretches out towards Argentina, all right, to give you a little bit of orientation here, as this is kind of the bottom of the world, okay? And there's a lot of other research being done in Antarctica. Specifically, we're talking about research happening in this region, okay? So a little bit of context here, a little bit of business understanding, okay? Well, what comes next after business understanding is data understanding, right? We want to be able to say what the species of a penguin is based on its physical characteristics, okay? And be able to do that and make predictions along those lines accurately, all right? So let's dig into the code and let's get this data in here. First thing is I'm going to import these two helpful Python libraries. Seaborn is a library for generating graphs, and Pandas is a library for manipulating our data, loading it, cleaning it up a little bit. And so you're going to see that most of the code we write today is specific to these two Python libraries. All right? And this is one of the reasons why starting off from square one with Python today would take a while. It would take a minute to be ready to use these libraries. However, when we use these Python libraries, the code we write is somewhat self-explanatory. All right, let me show you what I mean. Okay, first off, we're going to start off loading the data set here. Our intrepid scientists went out to 3 different islands here in Antarctica, and they wrangled some penguins, okay, and took some measurements about them. Let's see what measurements they grabbed. I wish there's like a video of that. I don't know, do they like use a net? Do they have to like chase penguins? Are penguins fast at running? I don't know, okay? But I wish I could see that. Oh, so I got an error message here. That's because I think I forgot to run this cell here above. Oh, it's not load data, it's load data set. Excuse me, I was calling the wrong function here, okay? So I'm using the Seaborn library, and what do I want that Seaborn library to do? I want it to load a data set. And what data set do I want it to load? The penguins data set, right? So on a high level, or at least a medium level, I hope you can follow this code, even if you're not completely clear, like why is there an underscore here? Why is there a period? Don't focus too much on the specific syntax for today. All right, now we're gonna look at this data set. Specifically, I want to look at the shape of this data set. How many rows and how many columns does it have? Okay, so I'm gonna say penguins dot shape, okay? And this tells me that this data is made up of 344 rows and 7 columns. What does that mean? Okay, let's take a look again. We can look at the first 5 rows of this data, also called the head of the data set, by saying penguins.head and then parentheses. Okay. This shows us the first 5 rows of the data and also what we call the column headers. Okay. This data is in the format of what we call tabular data. Tabular data, a very common type of data we work with as data scientists, meaning that the data is held in a table or a grid of rows and columns, right? And each row of this data set here represents a different penguin, okay? The species of that penguin, the island it was found on, its bill length, its bill depth, its flipper length, its body mass or its weight, and its sex, right? So each row is a different penguin, and each column is a different attribute of that penguin, or also of all the penguins that we have, right? So we're going to access specific columns here. Say I wanted to do something specifically with the bill length of all the penguins. We'll use this column header to access this one specific column and do things with it, okay? And I'll show you how that works here in a minute. All right. So I'm going to make a little comment here. I want to explain with these green comments everything I'm doing. So if you put a £sign in front of a line of code, it will comment it out, kind of just leaving notes for ourselves. I'm going to look at the first 5 rows of the data set. Okay. Penguins.head, right? So we loaded the data set and it's saved in this variable penguins. So we're saying do things with the data set. What is the shape of the data set? What are the first 5 rows of the data set? Right? So I hope you can follow along with this and see what we're trying to do here with the code that we write. Okay. When it comes to our data set here and the predictive task we want to pursue, all right, one of these columns in the data set is much more important than all of the others. I want you to think about that for a minute. Which column do you think is the most important? Remember, what we're trying to do is predict the species of penguin based on its characteristics or attributes. Okay. Now, I would say that the species column is the most important column here, right? Because that tells us what the species of the penguin is, right? That's the thing that we want to predict, right? We call the thing that we want to predict, we call that the y variable, right? In this case, species is the y variable. It's the thing that we want to predict. We want to take all these other columns to make a prediction about the species of the penguin. All right. One thing I want to point out here is some of these things may, just make inherent sense to you. The flipper length makes sense. The sex makes sense. How much the penguins weigh. But what is bill length and bill depth, right? I want to show that bill depth is kind of like the vertical shape of the penguin's bill, measured with calipers or something like that. But the bill length kind of goes from head to tip, all right? That's what those 2 measurements represent here. So hopefully we can also understand what all these columns represent and what their measurements show us. Okay. All right. That being said, I want to dive into the y variable here and say what can we understand about it. Okay. And in order to do this, we need to select a single column of our data, right? So we're going to start with penguins. That's our data. And then I'm going to put on these square brackets. Anytime I put square brackets next to a data set variable, it says, get me a part of that data frame. These square brackets are saying, go and grab a portion of it for me. And what is the portion I want to grab? Well, specifically, it's the species column. Okay. And if I run this code cell as is, by the way, you can run the code cell by clicking on the plus sign in the top left corner, or you can do Shift Enter, and that will automatically run the code cell for you. Okay. You can see here that in this manner, I've grabbed just the species column from my data set. And that's all that I'm working with here. Okay. Well, you can see that I've got a couple of, at least 2 different species of penguin here. If you've glanced down at the table below, you'll see that there's actually 3 species. How could I know that? And how could I know how many of each species are in my data set? Well, I want to count up all the different times we have an Adelie penguin, a Gen 2 penguin, and a chinstrap penguin. So the way I'm going to do that and count up those values is using the .valueCounts function, right? aptly named. Okay, and when I do that, it tells me that in this species column, we have 152 Adelie penguins, 124 Gen 2 penguins, and 68 chinstrap penguins. All right, and just for a little context here, here's what they look like. Right, they look a little bit different, and you can already see in these images, their bill sizes are a little bit different. Maybe their flipper lengths are a little bit different on average. It's hard to see a size comparison, right? But maybe some of these penguins generally are bigger than the other penguins or are heavier, right? We want to be able to take these measurements and know what penguin are we working with. All right, so that's the Y variable. 3 species. Most of the penguins are Adelie, right? We don't have very many chinstrap penguins. And by the way, the chinstraps are among the group of these 3 penguins whose population numbers have been decreasing the most rapidly in recent years and are a focus of conservation efforts. Okay, so we've looked at the Y variable. We understand some things about it. Next, we're going to take a look at the categorical variables. What do I mean by categorical variables? I mean, besides the Y variable, columns in my data set that can only take on a specific set of values. For example, sex can only take on 2 values for the penguins here, male and female. All right, it's a categorical variable because there's only those 2 categories and nothing else. All right, island is similar. We're going to see here that we have 3 islands, and it's specific. A penguin has to come from one of those 3 islands or not. There's no other options in regards to the data we have here. Okay, so let's take a look at that. We're going to do a similar thing here, where we're going to say penguins, and then sex. We're going to do islands first. Do value counts here. Okay, most of the penguins from Biscoe Island and Dream Island, and then a few from Torgerson Island. Okay, again, in terms of business understanding, where are these islands? Well, if here's the Antarctic archipelago, Torgerson and Dream Islands are really close to each other. And Biscoe Island is kind of off a ways, right? And this makes me think, if these penguins have specific, nesting habits or something like that, would the penguins on Biscoe Island be inherently different from the penguins on the other 2 that are much closer to each other geographically? I don't know, but this might be a question I would want to further pursue. All right, 3 different islands with our categorical variable here. Okay, the next categorical variable, and actually the last categorical variable, is the sex column. And again, we'll do a value counts. And we see that we have 168 male penguins, 165 female penguins. So about 50-50. Maybe the scientists tried to get an even number of males and females. Maybe it's hard to tell the sex of a penguin just based on how they looked, and so they just grabbed a bunch of penguins and by random chance it ended up being about 50-50. Either way, in our data set, it's about 50-50, which is good. It means we have data about both sexes here. All right, those are the categorical variables. They can only take on specific values. All right. However, you may have noticed that we have 4 columns left that we haven't talked about. Let's see, I scrolled too far. All right, we haven't talked about bill length, bill depth, flipper length, and body mass. Right. By the way, these measurements are in millimeters and in grams, so you can see the units there. All right, and these columns are a different kind of variable. We say that they're a continuous variable because they can really take on any value. They're not limited to male or female. They could take on any number here. The bill length could be 0 to, I don't know, within a reasonable range, they could take on any specific value. Now, these scientists have measured, it looks like, to 1 decimal point. But if we had a really precise measuring instrument, we could go off to a lot of decimal places here, right? Now, the usefulness of that, you may debate, right? But these 4 columns are inherently different from the island and the sex column in that they can really take on any value within a range. That's why we call them continuous, because they can take on any value on that kind of continuous number line from high to low. All right. So one way we can kind of get our heads wrapped around these continuous variables is by looking at what we call their descriptive statistics. The way that we grab these descriptive statistics is I start with my data set and I say dot describe. Get me this descriptive statistics of the continuous variables. And we get this table. Right? I hope you can see by now that the code that we write, not too intense, okay? And we get to a lot of value for a little bit of code. That's the value of these Python libraries here. They're kind of magic, right? What we're seeing here is a whole bunch of different descriptive statistics reported to us, including the average or the mean, right? We also have the median. The 50th percentile here is the same as the median. We can see the min and the max. That'll tell us, what is the biggest or smallest penguin or their biggest or smallest measurements in this data set. And also the standard deviation tells us how much do these measurements vary on average. All right. So things that you may have encountered before, harkening back to a previous statistics class or something, right? These are some of the descriptive statistics. Can help us get an idea about, okay, how do these columns vary, right? What would be a reasonable bill length for a penguin, right? Well, probably something between 32 and about, let's say, 60 millimeters. Well, that'd be a reasonable bill length, something along that range. All right. Okay. Again, I put this here again as a reminder of what bill length is as opposed to bill depth, and that's why we see a larger average bill length compared to bill depth because penguins' beaks are longer than they are tall. Okay, we can see that reflected here in those averages. Alrighty. What can we do next? Well, the continuous variables are a little bit more interesting. We can look at their distribution. As they could take on any range of values here, we might want to generate something like a histogram. All right. A histogram is a kind of plot that we can use that shows us the frequency of values along a range. All right. And so we can see, okay, how many penguins have small beaks, how many penguins have large beaks, etc. Kind of looks like these clumpy bar charts. All right. And we are going to use the Seaborn library to make a histogram. So I'm going to Google the documentation here, and I'm going to let you in on a little secret. Okay, seaborn.histplot comes up here for Seaborn histogram. Okay, this is the function we're going to use to make a histogram. And here's the secret. Seaborn has some documentation here about how to use this function, but way down at the bottom, they have examples. And guess what data set they use in their examples? They use the penguins data set. Okay? So if you look at any of these graphs and you go, oh man, I like the look of that graph, today you can literally just copy and paste this line of code into the notebook and it will run. All right, so we're going to do this here. We're going to scroll down and we're going to try and find some graphs that we like the look of. Okay? Particularly, I'm interested in having our histogram split up based on the species, based on that Y variable, right? Because that's the thing that I want to predict. And I want to see how does the flipper length, for example, differ between Gen 2 penguins, chinstrap, and Adelie, right? Looks like Gen 2 penguins have longer flippers than either of the other two, right? So I think this is an interesting kind of graph, all right? Let's see. Let's grab that. Let's have this be our starting place. I also like that it's a little bit transparent so we can see when these distributions overlap. It'll give us an idea of that. So let's use this as our starting place. Okay. sns.histplot. Then we tell it the data set we're using. That's the penguins data set. Then we tell it the column we want it to make the histogram of. In this case, we're looking at the flipper length column, and we want the colors of the bars to be based on the species column. And here's what we get. Okay, one line of code, we get a fancy graph. Okay, now we've kind of got this funny output here at the top. We can get that to go away if we put a semicolon at the end of this line. Okay, Now, semicolons are not a big thing in Python. This is just a funny trick that happens to pop up when we're making graphs. If you want that funny output to go away below the cell, this guy right here, you just throw a semicolon on the end. I'll do it again. Okay. And there's something else I want to do to these histograms. Okay. I'm going to add another parameter here. I'm going to say KDE equals true. I'll show you what this does. What this does is it takes our histograms and it tries to kind of make like a smoothed out version of them and places that over the histogram. Okay? Because my goal today, if it's to classify penguins based on their attributes, well, I might want to know, where do we stop seeing attributes of Gen 2 penguins, for example, and start seeing attributes of the other penguins, right? And find some vertical kind of cutoff here, right? So maybe somewhere around 205 millimeters, right? If I see a penguin with flippers bigger than or longer than 205 millimeters, I could probably safely say that that's a Gen 2 penguin, right? So what is making this graph really helping us to do? Well, it's helping our eyeballs and our awesome brains be able to see patterns to this data and be able to make observations about how those patterns are related to our y variable, right? And this is the same thing machine learning algorithms do. They look at patterns in data, try and associate them with the y variable, and tie them together, right? Be able to learn things about one specific column that will indicate to us what the correct prediction should be. All right. So we're going to do this with the other columns as well, the other continuous columns, right? So I'm going to paste this down into these three cells, and we're just going to change this x variable here to be, let's see, bill, I believe it's bill length in millimeters. There we go. There's the bill length. We're going to have the bill depth in millimeters, right? Again, this is just a column header from my data. Okay. And then last but not least, we have the body mass in grams. So the thing that I'm interested in, if I'm the machine learning algorithm here, is how can I classify these penguins? What is it about these measurements that gives me a good idea about what kind of penguin you are, right? So we're really interested in places where these graphs don't overlap, where they're kind of split from one another. One thing I can do here with my data to make it a little bit more apparent where they break apart is I can increase the bin size. And this is what it's going to do, is just change it so that instead of having 10 columns of data here, I'm going to have 20 columns of data. So see how the columns got a little bit smaller? And I can see a little bit better now where those distributions are separated. Okay. So I'm going to add this bins equals 20 to each of my function calls here, to each of my graphs. And that might give us a little bit better perspective. All right. Okay, so this tells me flipper length, pretty good at isolating Gen 2 penguins. With flipper length alone, I have a pretty good idea of if it's a Gen 2 penguin or not. Okay. Similarly here with bill length, that gives me a good idea if a penguin is an Adelie penguin or not, because Adelies have short bills. Okay. If I look at bill depth, again, that's going to help me isolate Gen 2 penguins. And then last but not least, like I've seen good ways of isolating Gen 2 penguins. I've seen good way of identifying Adelie penguins. But what about these chin strap penguins? They're kind of always together with something else. How could I differentiate between those? Might be tricky. Might be tricky with what we've got here. But I would say that maybe bill length can help us do it a little bit. Or some combination of these could help us, differentiate between the penguins here. Okay. Again, we're using our brains as the machine learning algorithm for looking for the patterns and saying, okay, how can I classify? How can I split these into groups? so that their species is correct, right? Or so that group is all of one species. That's really my goal here as we make these graphs. All right. Last thing we're going to look at, and then we'll go back to our questions here, and maybe we'll take a short break as well. We're going to look at how does island relate to species. Remember earlier I had this question about, Bisco Island is, I believe that's the name of it, is far away from the others. Is that somehow related to species here? Well, I can look at the kind of interplay between two categorical variables by using a tool here called a crosstab. Okay. Now what I'll do with this crosstab is I'm going to pass it two different columns, specifically the island column, and then I'm going to pass it the species column. Okay. And let's see, I have a typo here. Penguins is not a thing. Penguins is a thing. All right. So we see penguins on the different islands here, and we also see the different species. And I think this is a really interesting table. Okay. Why? Because if a penguin's on Torgerson Island, I know that it's a deli, right? It's the only kind of penguin on Torgerson Island, at least according to our data set, right? If a penguin is on Bisco Island, right, 70% chance that it's a Gen 2 penguin, all right? Assuming that we've pulled penguins at random from these islands, all right? If a penguin is on Dream Island, 50-50 chance if it's a deli or chinstrap, right? So there's quite a lot of helpful information in just the island the penguin comes from in helping us identify the penguin. Okay. Now what I really love about these crosstabs, these tables, is they're really easy to make cool plots. If I say .plot on the end of this line of code, I just copied it from this code cell above. Okay. The pandas library will generate a graph for me. Okay. Well, this starter graph isn't super useful. Okay. What I need to do is there's another parameter here I can pass to the plot function, and I can say kind equals bar. And then I'll get a bar chart instead of that funky line chart. Now I'm seeing the values in this table graphed as bars across the different islands. Pretty cool. Let's do this again. I'll show you a different parameter that can alter this. Instead of having these be individual bars, I can say stacked equals true. And then they'll kind of be stacked upon one another. So I can see that, okay, Bisco Island has way more penguins than Torgerson in general, right? But the Torgerson penguins are all a deli. So it looks like we find Adelie penguins pretty much wherever, but we only find chinstrap and Gen 2 penguins on these two specific islands. All right. Last but not least, okay, I can visualize this crosstab in percentage terms. Adding another parameter here, I could say normalize equals index. Okay. Don't focus too much on the code here. Focus on, whoa, I added, 20 characters of text here and got a completely different graph. Graph that does something different, a graph that tells me something different. Maybe the code for this data science stuff isn't so bad after all, right? At the end of the day, this is still one line of code. It's not a simple line of code, but we're doing cool things with relatively little code, right? So I hope this eases a little bit of your worries about needing Python familiarity to follow along today. I hope I haven't lost you. All right. So this is the same data we saw above, but now seen in percentage terms, right? So a little over 50% of the Dream Island penguins are chinstrap, and close to 78% of the Bisco Island penguins are Gen 2. All right. So cool that we can make this table and then very easily generate different helpful graphs from it. All right. So at this point, we have thought about the business problem, and we've taken time to really understand our data and understand how our data relates to the Y variable specifically, right? The most important column, which is the species column, right? So at this point, feel like we've got a good understanding. We know what we're after. We're going to take a look at some machine learning algorithms next and see how they work as we train our model. All right. Again, I'll answer this question when we get to the end. Is it considered good practice to use the semicolon similar to JavaScript? No. So this is the only time you would ever use a semicolon in Python. Semicolons are not a thing in Python. You don't need them at the end of a line. The only reason I'm using this semicolon is because it happens to cause this funky output to go away. Right? And that's more a symptom of that we're using what we call an IPython notebook here, where we've got a whole bunch of different little code cells. If I was working in a plain Python notebook, this semicolon wouldn't really do anything. So it's kind of just a Google Colab almost specific trick that we have up our sleeve. It's not really something that's inherent in the Python language. Good question. Is there a way to show the value counts of nans for each column? Yeah, great question. So you may have noticed, and this is something we'll talk about in a minute, pardon my scrolling, we have nans in some of these columns. In other words, there's missing data. I don't know what happened here. Maybe they grabbed this penguin on Torgerson Island and then it slipped away and scampered off and they didn't finish taking its measurements or something like that. But for whatever reason, we're missing some measurements for this penguin. And when we load data, we fill in those missing measurements with nans. Stands for not a number, meaning we just don't have anything here. We can look at the nans for, let's look specifically at the sex column, for example. Find out where we did that again. Oh, it was up above because that's a categorical variable. Okay. I can say, let's see, what is the parameter here? I don't have it memorized. Is it drop NA? I'll have to Google it. So even me, I've used value counts thousands of times. I still can't remember all the parameters, right? So don't be afraid to look things up. Don't be afraid to Google things. You're never going to memorize it all when it comes to code syntax, which is another reason why I'm not really emphasizing it today. All right. Okay, so we have drop NA, and the default is true. I can set that to false here. And then it will also include nans. So this looks like for 11 penguins, we don't know their sex. All right. So very good question. Yeah, we can include those as well in our value counts output. All right. Oh, can you go over what normalize does again? Okay, yeah. So normalize just takes things and turns them into percentages. Okay. So the only place we used it was right here. I guess maybe that's one of two places. Okay. We had these different categories, and I said, okay, well, what percentage of all the penguins on Dream Island are chinstrap versus Adelie, right? That's why these bars now reach up to 1 or 100%, because we took the rows of our crosstab and turned them into percentages. I can also get the same thing here if I say normalize equals index. Right. Now, across each row, these should add up to 1, right? 100% of penguins, Torgerson Island penguins are Adelie, right? So this is just taken our previous output and turned it into percentages. Okay. So I'll leave a little note here. Turn the table into percentages by row. And then I'm going to take the normalize off up here so you can see both versions. The regular table and then the normalized table. Normalize just means turn into percentages. All right. This is great. However, how do I start learning more basic Python? I will, let's see. What I will do is at the end of our discussion today, down here at the bottom of the notebook, okay, I'm going to put some Python learning resources. Okay. Ryan will add later, right? I have some favorites, and I have honestly a whole bunch of references I want to give to you. I will put them in the bottom of this notebook. a little bit after our discussion today. One of my favorite sites is DataCamp. They have some great free resources. There's also a website called Kaggle.com, and they have some learning resources, okay, where you can learn Python, intro to machine learning, intermediate machine learning, data visualization, pandas, SQL, right? A lot of the things I mentioned are the places to get started here, okay? So I will generate a list of some of my favorites here and add them at the bottom so that, if you were hoping to get more specific Python syntax today, you can jump into those resources. Great question. I don't want you to wait. I'm unable to load the data set. Am I supposed to be able to load these tables on my computer? So, great question. You will load this data here in Google Colab. Right? So you shouldn't need to download any file to your computer. Everything is going to happen within Google Colab. All right. Let's see here. Yeah. If you're unable to load the data set, make sure that you have imported these libraries. Once you have run this code cell, and by the way, you can tell the code cell's been run because a number will show up in the top left corner. If there's no number here on the side, then the code cell hasn't been run. Okay, and that number tells us the execution order of the cells. So this was the 19th cell to be run, 21st, 22nd, 24th, etc. Okay, make sure you've run this cell, and then this should load the data set for you. If you're in Google Colab, all right. If you are not in Google Colab, if you're trying to use some other application here, you might run into some trouble. I hope that helps a little bit. Okay, Juan asked a great question. He says, what is data mining? So data mining back in the day was thought of as being a process of you have a big database or multiple databases. How can we query information from those databases and gain insights about our data, or use data that we already have to make decisions, right? It does not necessarily involve machine learning models, where data science does. It's more about pulling data from databases or other stores of data, and then using some statistics and basic analytics to learn things, similar to the exploratory data analysis we're doing right now, all right, and that we've just completed. It doesn't necessarily involve machine learning or making predictions. Data mining is kind of like a subset of this big umbrella of data science, right? This is my data science umbrella. Data mining's, one portion of it. Great question. All right. Thank you for your questions here. We are going to take a 5-minute break here. Get up, stretch your legs, get a drink if you need to, use the restroom. You're probably tired of listening to me talk, so let's rest our brains for just a minute. All right, 30 seconds. Come back and find your seats again. Take a deep breath. Okay. I know it can be tough to have someone talk at you for an hour straight, especially at the pace that I tend to go sometimes. I'm glad you're still here with me, all right? But our brains need a break. So I hope you took a little bit of a break with me, ready to dig in again, okay? Let's talk about where we've gotten so far. Well, we've gotten to data understanding in an hour, all right? We haven't even touched machine learning yet, okay? Data science is a lot more than machine learning, even though that is an absolutely critical piece. But in my opinion, maybe sometimes overemphasized in the bigger picture. That's part of what I want to show you today, okay? So we're through data understanding, and now we're gonna do a little bit of data cleaning. But before we get to that, I want to talk about why we're gonna do the cleaning that we're gonna be doing, right? A machine learning algorithm, or an algorithm in general, all it is a set of instructions that the computer follows, right? You may have done an activity in the past about what is the algorithm to make a sandwich. If you had to write down instructions for someone so that they could make the perfect sandwich every single time if they followed your instructions to the letter, right? What would your instructions look like? How specific would they have to get, right? Maybe your algorithm is get 2 pieces of bread, put some meat in between those pieces of bread, you have a sandwich, right? Well, you might end up with something like this, right? I mean, like, is it a sandwich? Like, technically, like, yes, I guess, but it's wrong. It's just wrong, right? So our algorithms are sometimes like this, where we have to be really specific in the instructions that we give them so that they operate correctly. Otherwise, we might get wonky results, all right? And this is why we have to clean our data up a little bit before we use the machine learning algorithm. There's 2 important things we're gonna have to do. We have to remove NaN values. Our machine learning algorithms doesn't like those NaNs. It doesn't want to see any missing data. So we're gonna actually just drop or remove any rows that have NaNs in them to take care of that issue. And then the next thing is machine learning algorithms do math. That's part of the instructions that they operate on, right? And so we can't do math on text data. So what we're going to do is we're going to replace these different values in the different columns of our data set with numbers, these integer values, 0, 1, and 2. And then our data set will have no missing values, and it'll all be full of numbers. It'll all be numeric, and it'll finally be ready for the machine learning algorithm to go after, all right? So one thing I want to emphasize here is that, what is the algorithm doing at the end of the day? Well, it's kind of looking at the histograms like we are and saying, okay, how can I isolate the Gen 2 penguins? How can I isolate the Adelie penguins? What is characteristic of them? It's looking at those patterns in data and trying to associate those with a prediction, with a Y variable, right? As a little demonstration here, here's a website called playground.tensorflow.org, linked to here in the notebook, okay? And this is actually a simulator of neural networks, okay? And I'm gonna use a really complex data set. It's got a lot of twists and turns. It would be challenging to classify this. It's a lot of complexity here. And if I have a really simple model, okay, something like this, my model's not gonna make very good classifications. Notice it's just drawing a straight line in between things, okay? Now, that might be easy for me to wrap my head around. I can understand, like, oh, are you on this side of the line in the orange area, or you're on this side of the line in the blue area? My model's easily interpretable, but my model is not very complex. And often these 2 things work against each other, right? The more complex my model is, the better it might do, or the better it can fit non-linear patterns in the data, but also the more difficult it is to understand, what was the steps that algorithm took to arrive at that result, all right? So in contrast to this very simple model here, this is actually a neural network. We're not working with neural networks today, but just as an example, I'm gonna make a whole bunch of layers here. I'm adding neurons, right? I'm making this model much more complex, okay? And then let it fit to the data again. And notice now it can kind of twist and turn, and it's trying its best to fit the curve of the spirals here. Oh, it's getting closer and closer and closer. Pretty good. Not perfect. You see its accuracy is jumping around a little bit, but way better than what we had before. Okay, so we fight this trade-off in machine learning where complex models, they're hard to understand, hard to interpret, but they can fit lots of wonky patterns in our data. Simple models can't fit as complex of patterns to our data, but they're really easy for us to understand why they're working the way that they're working, right? So today we're going to focus on a simple model, right? Because it's, if we're scientists and researchers here, we don't want to just be able to predict what species of penguin we're looking at. We want to know, why is that the species of penguin we're looking at? What is it about a Gen 2 penguin that makes it a Gen 2 penguin, right? Is it its flippers? Is it its bill, right? What are its characteristics that are, characteristic of that species, all right? So that's really what we're after. And this is why we're going to use a little bit of a simple model today. But you're going to see that even though we're going to use a simple model, it's going to be still a machine learning model. It's still going to be get pretty good results, all right? So I mentioned before, we've got to do a couple of things here. I'm going to do this section a little bit faster for time's sake. I don't want you to focus too much on this. Just know that we're going to drop any rows with NaN values, all right? And we are going to replace the string values in our data set with integers, 0, 1, and 2, all right? So to remind you, look at the first 5 rows. We've got some NaN values. We don't like those, all right? If we look at the number of rows and columns, we currently have 344 rows of data. Well, how many NaNs do I have in each of these columns? I can say, hey, penguins data set, right? Tell me if any of your cells are null or not, and then count all those up for me by column, right? It says, oh, we have 11 missing values in the sex column, and it looks like we also have some missing values in the other continuous columns, but we know the species and island for all the penguins, okay? So it looks like of the 344 observations we don't have that much missing data, something like maybe 3%. So it's not going to be a horrendous blow to our sample size here if we remove these, all right? So we're just going to drop them. This is one of the simplest ways to deal with missing data. We're going to call the drop NA function, and that's just going to remove any rows that have NaNs in them, right? And then we're going to look at the shape here to see how many rows we lost. And we went from 344 rows to 333 rows. So 11 penguins got removed because we were missing some data about them. But we still got a lot of penguins to work with. So we're in good shape. All right. Last but not least, I've left this code in here because it's a little bit complicated, right? We're starting with the species column, and we're replacing a deli with 0, Gen 2 with 1, chinstrap with 2, right? So before I run this cell, remind you what our data set looks like, right? We have Adeli, Torgerson, male, female. I want to take those pieces of text and replace them with these corresponding integer values. So if I do that, and then call.head, you can see that now they've all been replaced, right? Now, one thing that I'll mention here is that these are in order of the most common value, right? So Adeli is the most common species, Gen 2 is the second most common species, chinstrap is the third most common, okay? This is something that we call categorical encoding, all right? And this specific technique, there's multiple ways of doing categorical encoding. This is called label encoding, which essentially just means replace the strings with integers, right? Replace them with numbers, right? Label encoding, it's one of the most basic ways of making our data all numeric and ready for the machine learning algorithm, okay? So that was step 3 of our CRISP-DM. I should move this down so I don't have to scroll up every time because CRISP-DM is way over here. So we've done data preparation. We're finally ready for modeling, okay? what we're going to do here is we're going to write a function to classify our penguins. All right. We're going to use this function to look at each penguin individually, right? And tell us what species it is. All right. However, before we do that, we need to split our data up. Okay. So what's going on here? We're using a different library here called sklearn, and I've imported this function called train test split. Well, I want you to imagine that you are studying for a math test. All right. And your math teacher gives you a study guide or like a pre-test or something like that before the math test, right? You are going to do your best to learn everything that's on that study guide, and you hope that that study guide is similar enough to what's actually going to be on the test that if you learn it well, you do well on the actual test, right? So we have a similar scenario here with machine learning. We want our algorithm to take some of the data, we're going to call that the train data set, and learn the patterns in that data. Learn how those patterns relate to the Y variable. That's like its study guide, right? It's trying to learn the patterns, and then we're going to give it the actual test. But when we give it the actual test, we want to see, okay, how well have you learned the patterns in the data, machine learning algorithm? When we do that, we're not going to give the machine learning algorithm the Y variable when we're testing it, right? We're going to say, hey, take everything but the Y variable, everything but the species column, and tell me what you think these penguins are, right? And then we'll take those predictions and compare them to the true penguin species, and we'll see how well did our model do, right? So our training data here is like our study guide. We're trying to learn, what's going to be on the test. And then in the test data set, we're going to actually see, okay, does our model know its stuff? Can it actually make good predictions? Okay. So what I'm doing here is I'm splitting the penguins data set into two halves, 50-50, right? So you can see here that half of the data set is in the train data set and half is in the test. Okay. Now, I also have this parameter here called random state. If I don't include this, then our penguins will be split up randomly every time I run this. So watch these numbers on the left-hand side. They all change. We have a different 50% of the penguins here in the train data set. And if I run these code cells again, we get a different 50%. All right. But if I include that random state, well, I'll still get a random version of the training and the test data set, but it's going to be the same random version every time. Okay. So by using this random state, you and me and your cousin and your professor, right? If we ran this code cell, we would get exactly the same results, even though we're still splitting up our data set in a random fashion, right? Makes our code more reproducible. And so that you should get exactly what I'm getting if you're following along, if we're using the same random state. If you change the random state, goes out the window. Okay. So we've split our data into these two halves, and we're going to use the training data set to classify these penguins. Okay. So our training data set is a data frame, and we're going to write a for loop over this data frame, right? So this index variable keeps track of which row in the data frame we're looking at, and then the penguin variable here is going to represent each individual penguin in our data set. So we specifically want to look at the train data set, and we want to iterate over the rows of that data set. We want to look at each one individually, right? So if I print the penguin here, you'll see that we're looking at each penguin one by one. One penguin here, one penguin here, one penguin here. We're iterating over those rows and looking at each penguin individually. Okay. Well, what I want to do is I want to take this penguin's information and I want to pass that to a function here. We're going to call this the classify function, and it's going to take in a penguin, right? And then what's it going to do is it's going to do classification, and it's going to return some species, right? It wants to take in these attributes of the penguin and say, okay, this is the type of penguin that it is. All right. So what we're going to do here is we're not just going to print out the penguins. We're going to pass them to the classify function. Okay, and then we'll print out what gets returned here, which in this case is just going to throw an error. Okay, because we haven't defined this species variable anywhere. Oh, and I have a typo. That's also a problem. Okay, it says species is not defined, right? I'm returning this variable, but I've never said, what the species is. Okay, so here's what we're going to do. We are going to scroll way up to our graphs here, and we're going to pick a couple to help us isolate the penguins. Specifically, we are going to look at the bill depth, all right? And we're going to pick a value that we think is going to isolate the Gen 2 penguins on their own, right? So if I look at, kind of where these cross, somewhere in this region, maybe a value like 16.5. Okay, I'm kind of just eyeballing it here, right? Where is the dividing line between the bill measurements between Gen 2 penguins and everybody else? Okay, so what I'm going to do here is say, getting way back down to it. Okay, if that penguin, the one we're looking at, because we're going to look at each one of them one by one, if their bill depth in millimeters is less than 16.5, well, then we're going to return Gen 2, right? We're going to say that that's the species we're returning. Okay. Well, if it's not a Gen 2 penguin, well, then it's got to be one of the other two. Okay. So we still have to handle the other two species down here. Okay. And we're going to look at a different variable for that. Specifically, in our case here, we're going to look at the bill length, this guy right here, and say, okay, so I want to now isolate the Adelie penguins, okay? And we're going to say that if the bill length is less than maybe 43, that'd be a good dividing line. Now we're just eyeballing it here, but that's okay, right? If the bill length is less than 43, then it is an Adelie penguin. There we go. Thanks, brain and eyeballs, for doing that machine learning for me. Okay. All right, so if it's not a Gen 2 penguin, then we want to say if the penguin's bill length in millimeters is greater than 43, then return I believe that's Adelie. Otherwise, right, if we haven't covered Adelie in Gen 2, then return chin strap. Okay. And I want to double check, make sure I haven't mixed these up. The Adelie and chin strap here. Looks like Adelie is 0, chin strap is 2. I do have them mixed up. I want this to be chin strap, and I want this to be Adelie. Okay. I have a function. It has learned from my data, right? How did we get these thresholds or these cutoffs, these heuristics, from the patterns in our data that we saw with the graphs, and that our brains, the amazing pattern detection machines that they are, helped us see where those cutoffs should be, right? So we are associating the patterns in our data with a specific prediction here. This is a machine learning model, all right? Now you're saying to yourself, it's just some if statements, okay? And there's a long-running joke that that's all that machine learning is a bunch of if statements. That's absolutely not true, but for the very, very simplest models, maybe a little bit true, all right? So we're now classifying our penguins. Let's see. It says species is not defined. Oh, I forgot to rerun this cell. Every time I modify this code cell, I need to rerun it in order to save that function in my code cell's memory. And then I can classify some penguins here. Bill depth in millimeters is not defined. So I need to put this in quotation marks. Got a little typo here. All right, rerun that cell, rerun our predictions. Hey. So we're looking at the different attributes of the penguins, and we're outputting a bunch of predictions. But we have a problem here with our predictions, is that we changed our species column to be numbers. And now it's outputting these names. So what I'm actually going to do is I'm going to change this function. Okay. And instead of returning gen2, I'm going to return 1. Instead of returning chinstra, I can't even spell chinstrap right. We're going to put a 2, and instead of returning a deli, we're going to put a 0, right? Now the predictions that we're outputting match the data that we have. Okay, so we've written a machine learning algorithm. We have a classifier. It can take the penguins, bill depth and bill length, and tell us what kind of penguin it is. But how good is it at telling us that? Let's evaluate this model. Okay, so what we're going to do is we want to make some training predictions. Okay, and we're going to save those to a list. Okay, and then same for loop here. Right, we're going to loop over our penguins, but after we classify each penguin, we're going to put our predictions in this list. Okay, so in the train predictions list, I want to append my predictions that are being returned to me from the classify function as we look at each specific penguin. So we should end up, unless I've made a typo here, with some training predictions, and it looks like it's predicting 0 everywhere, and that seems problematic. It should not be 0 everywhere. It should change between them. Let me see if I have goofed this up. There we go. I had a typo somewhere. I don't know exactly where. I said penguins rather than penguin. So I had an S there. That's causing that typo. Okay, so now we've got our predictions. We can look at our training accuracy. We're basically saying, okay, of the predictions we made, how often did we make the right prediction? Okay, given our training data. So we're going to say, take our trained predictions, compare them to the true species. Okay, and we're going to get a whole bunch of, this needs to be an underscore, true and false values. Okay, it'll be true wherever we made the correct prediction and false wherever we made the wrong prediction. So we can count up all of the instances of true, right? And let's see, unexpected end of file. I need another parenthesis here. Okay, I made the right prediction 157 times with the training data set out of a total of 167, I believe. So on my training data, I made the correct prediction 94% of the time, okay? Just based on these two heuristics. Only looking at the bills of the penguins, I was able to classify them pretty well, okay? So I have just done the practice test. I've just done the study guide, right? My model has had all the answers to check its work. Now we're going to say, okay, model, are you going to work on data that you've never seen before? On data that you have not trained on? That's our next step here, okay? Well, we've got our test data set, right? But remember, we don't want to give our machine learning model the answers to the test, so we're going to split off the species column, and we're only going to give it X test. Don't give him the answers to the test until he's taken it, right? So we'll then generate test predictions in exactly the same way we did before, all right? And then we'll calculate our test accuracy the same way that we did before. But the comparison here is going to be a little bit different. We're going to take our test predictions, see if they're equal to y-test, add them up, and divide by the length of our test data set. Ooh, 89%. 89%. So our accuracy went down, okay? But that's okay. That's actually somewhat common, or very common with machine learning models. It's still close to 90%, right? We can still tell with 90% accuracy what kind of penguin we're working with just by measuring its bill. Remember, we haven't taken account anything else yet. The island, flipper length, anything else. We're just looking at the bills here. Okay. This is a decision tree, what we've made here. And it's actually a machine learning algorithm. Okay. Now, this is a simple version of one, but notice we're making decisions. So start off with a penguin, look at its bill depth. If it's a certain way, well, that's Gen 2. If it's not a Gen 2 penguin, look at the bill length, and that'll help us differentiate between the other two. Okay. I have some code down here that's going to do this same machine learning algorithm, but in a little bit fancier way. Rather than with just if statements, it's going to learn this information using a tried and true machine learning model here. Let's see. X is not defined. Did I forget to run this cell? No axis. Oh, I'm not sure what's going on here. Let's it's a series. I'm going to rerun some code cells because I think my data set got messed up at some point. Okay. You may find yourself needing to do this if something's happening wonky. We'll start back up at the top, and we are going to reread in our data set, and then we're going to clean it up, right? So in the section here where we dropped the nans, we're going to do that again. And we're going to do the categorical encoding again. And then my data set, whatever went wrong with it, should be back to normal. Okay. Down past our classifier that we wrote, we're now going to way down here. All right. Use this fancy model now. So what I'm doing here is I'm splitting off the y variable, and then I have all my other variables. So this lowercase y represents the thing I want to predict. This x variable represents everything else from my data set. All right. Now I'm going to split this up, do a train test split just the way I did before. Then I'm here using a library called scikit-learn to make my model, fit my model to the data, generate predictions, and then see how close those predictions are to the true values. Much what I did before, but summarized here for us in just a few lines of code, again, due to the helpfulness of some libraries that we've imported. Okay. And this library gets 91.6% for their accuracy. And what's cool here is we can visualize its decision tree. I don't know if you can see this graph here. And actually, it's kind of getting dark where I live. Let me turn on a light here. All right. So what did it do? It did the same thing as us. It looked at the bill depth first, but it divided it at 16.4. What did we do? I don't even remember. Because we just eyeballed it, right? But it's using math to try and pick the value that's going to maximize the purity of those groups. That's going to isolate the Gen 2 penguins the best. Way up here. Oh, we did 16.5 and they did 16.4. We did 43 for the bill length. And by they, I mean the library version of the machine learning algorithm. Oh, they did 42.35, so quite specific, right? And they did something else that we didn't do. They also, after they looked at bill depth and bill length, they factored in the island, right? So they said if the bill depth's less than this, well then it's a Gen 2 penguin, most likely. But if it's on a different island, then we're going to say that it was an Adelie penguin. Okay. Same thing here. After we looked at the bill length, if the bill length was less than a certain amount, we said it was an Adelie penguin. But if it was on a certain island, we may have said it was a chinstrap penguin. Right? So they took it an extra step further than we did. But this is a decision tree. Okay. Now, we're about out of time here. I will stay and do some of your questions here, but the last thing I want to show you is that a machine learning model is not very much good to us if it's just in a notebook here, right? So I have gone a couple of extra steps here, and I have deployed our model here as an API, okay? As an API. And now the links to these GitHub repositories are in the document for today, and they're also in the video description, okay? You can come and look at this API. Basically what it's doing is I just put in our classifier, right? And so this API is a program that lives on a server in some Google or Amazon data center. And what it does is it waits for inputs. And when it gets inputs, we send it a penguin and we tell it, the bill length and bill depth. It's going to pass it through this classifier and it's going to return to us, oh, I think that's a Gen 2 penguin or a chinstrap or an Adelie penguin, right? So it's essentially this machine that takes in inputs, forms a prediction, and sends that prediction back to us, right? And you can see here that our classifier is at the heart of it, right? That's how it determines, based on the inputs, what the prediction is going to be, right? So if we look at this a little bit here, right? This will let us test out our API, but I can say, okay, what if the penguin has a bill length of 35 and a bill depth of 15? Execute, and it says, oh, well, that's a Gen 2 penguin. Pretty cool, right? Well, the very last thing I'm going to show you today, okay, is I also have another notebook here, and this one I want to challenge you to work with on your own, okay? If you have to, review what I'm about to show you in the video right now, but I'm going to go a little bit fast, all right? What this notebook is, it is a website that's going to talk to that API, and we can type in our penguin measurements, and it'll tell us what penguin it thinks it is, all right? Again, we're just getting our model out of the notebook and getting it somewhere where people can interact with it, where lots of people can get predictions and use the smartness of our model, right? So what I'm going to do here is I'm going to fork this data set. I actually already have it forked, but that's step one. When you click fork here, it'll make a copy of this website files to your GitHub account, all right? So if you're following along, go ahead and fork it here. I've already seen that number jump up a little bit. Again, you're going to need a GitHub account to do this, right? But this will be in the recording if I get ahead of you a little bit here. Then we're going to come to a site here called Netlify, log in with our GitHub account, okay? And I'm going to say, Netlify, I want to make a new website. Host this website for me, please, but the website is on my GitHub, right? So it says create a new site. We want to create that site from GitHub. And it's going to ask me for permission to access my GitHub account. I'll grant it, but I'll see here that, oh, even though it accesses my GitHub account, it doesn't have access to this specific website files yet. So I'm going to configure the Netlify app on GitHub for my specific account. Okay. And then down here, I'm going to say, hey, Netlify, you can access the penguin front end repository. That's the one that we just forked. See the fork symbol right there? Looks kind of like a Y with circles on it. Okay. If I save that, now I've just given Netlify permission to access this file on GitHub. Okay. And that's what I want to use to make the site. So I go ahead and click on that and say deploy site. It's thinking about it. It's trying to serve it up for us. Okay. And now if we visit this URL here, you'll see a not very well-designed website that I made called the Penguin Predictor, right? And we can type in measurements for our penguin and hit submit, and it says, those parameters best match a Gen 2 penguin. And it gives us a whole bunch of information about Gen 2 penguins that I kind of borrowed from National Geographic. I linked to National Geographic down here below. That's where we got some of this number 84. But let's try some different measurements here. What about 40 and 20? What kind of penguin is that? Oh, that matches an Adelie penguin, right? So we've, at the end of the day, right, this is the deployment phase. We want to get our model out of the notebook and somewhere where it can help people, somewhere where it can provide value, right? Because that's what data science is all about. All right, so take a look at these if you get a little extra time. This is a stretch goal for today, right? You as a data scientist, you will not be asked, well, most likely not be asked to make websites, all right? What you are making is you're making the brain that fuels these predictions, right? You're making the model that helps generate these predictions, all right? So, well, is what we just did valuable, right? Was it data science? Well, is our model valuable? Maybe for the scientists, right? Is it more valuable after it's deployed? I think so. More people can access it now. What would make it better, right? Well, what would make it more valuable? Well, maybe if we had more kinds of penguins or something like that. Well, if we do that, we've got to go collect more data, right? If we want to include more penguins here and make our model even more valuable, okay, then we've got to go all the way back to data understanding and collect more data, all right? So this CRISP-DM model never totally ends. We just get to a point where we think we've stopped making big enough improvements to where it's not really worth our time anymore. But there's always little improvements we can make to a machine learning model. All right. Last but not least, I hope that this discussion was valuable. I hope you can see the big picture of what we try and do in data science. Get some data, clean it, explore it, fit a machine learning model, and then put that machine learning model somewhere where people can benefit from it, whether a website or an iPhone app or whatever the case may be. Maybe a car, if it's in a Tesla, right? Pretty cool. And I hope you feel like by the end of the day, if you follow the very quick Netlify demonstration here, you have something you can show off. You can go say to your mom, look at this thing that I made that tells you random penguin facts. I don't know. Maybe you don't think it's that valuable, but it's just a small example of bigger things to come. All right. That wraps up our lecture portion here. I am going to get to now some of these questions. All right. First thing, what is the entry-level salary for data scientists after taking Lambda School? All right. You can take a look at our website where we have outcomes reports that we publish quarterly, I believe. The last number I heard was that the average salary was $75,000. Actually, that's not the average, that's the median. Okay. Now, you may think, I thought data scientists made more than $75,000 a year. Remember, this is the very first job that people are getting in data science. And with a little bit of work experience, that number is going to jump up quite quickly. And a lot of those students in those jobs probably hadn't written any Python just 6 months before that, 6 to 8 months before that, right? So pretty cool. We see some of our top students consistently get six-figure salaries. Oh, twice a year for the report. Maureen's correcting me. We report it every half of the year, not every quarter. So go to lambdaschool.com and check that out for more specifics on the outcomes of our Lambda School students. What are the options Lambda School has for international students based in the US? This is a good question. Currently, due to legal constraints on Lambda School, you need to be a citizen or a permanent resident to attend Lambda School using an ISA. If you are an international student, you can attend Lambda School, but you'll have to pay the tuition up front. You can't use the ISA option currently, unfortunately. All right. Christina asks, can you cover epics a bit? You may have seen epics in the TensorFlow playground, which may have been a little bit distracting. It's pretty fun. And in the main Lambda School course, we do get to TensorFlow and make our own neural networks. All right. The way that a neural network works is we run data through the neural network and we see how accurate was that data, and then we adjust the weights of the neural network. And then we run another batch through and we adjust the weights. Then we run another batch through and we adjust the weights. So each epoch here is a new batch of data that's passing through the neural network. That's why you'll see the epoch counter tick up here. As we feed more and more and more batches through, our model's getting better and better and better as it's exposed to more data. So that's what an epoch is. Great question. How spot on do you usually try to get your training data? What percent or ratio do you try to get for good or sufficient data outcomes? That's another great question. So typically when I'm fitting a machine learning model, I'll start with what's called a baseline. And that means, what is the dumbest model I could possibly make? Even if I'm just saying like, oh, Adelie penguins are the most common in my data set, I'm going to say that all the penguins are Adelie penguins. And I'd probably be like right 60% of the time. All right. And then from there, I say, okay, what do I think I can do that's going to make the biggest improvement? Is it categorical encoding? Is it removing the nans? Is it picking a different kind of model that's maybe not a decision tree, right? And there's a whole kind of different sets of methodologies from that point on that gets a little bit complicated. But I don't necessarily shoot for like a specific percentage of accuracy or something like that. I'm searching for a model that's the most useful, right? And not a model that's perfect. And that's a little bit subjective value judgment here, but that's what I'm really after, is not any specific number. I'm looking for something that's useful. You've used single quotes and double quotes for your arguments and variables. Is there any significant difference in using either, or can we use either anytime? That's a great question, and I have a bad habit of intermixing them. In Python, it does not matter if you use single quotes or double quotes, but they have to match. All right, so in my notebook here, find an example. Okay, so I've got double quotes here, but I'm starting and ending this string with double quotes, right? Here I have a string and I'm starting and ending it with single quotes. So it doesn't matter which I use as long as they match on either side of the string. I couldn't use single quotes here and then double quotes here. Notice how this whole line went red? Python's confused, right? It needs to see another single quote to know, oh, that's the end of that column header. So you can use either as long as they come in pairs. Any suggested courses to take for the next data science cohort, i.e. LinkedIn Learning, etc.? I want to get a jump on the material if possible. The thing that I think helps our students become the most comfortable coming into the new course is to brush up on vanilla Python. All right, so again, I'm going to add those resources to the bottom of our notebook here. That is the number one thing I would recommend before you come to Lambda School, because you notice, we've technically been writing Python today, but it's all in the context of these other libraries, right? And it becomes a little bit confusing, like what is the library doing versus what is Python doing for us as the language itself. And the more comfortable you are with vanilla Python, the more this code will just read more like plain English. You'll just be more familiar with it, and you'll be able to differentiate between what's the library doing and what is Python doing. So that's what I recommend. Brush up on Python as much as you can. Can you restate the build settings for deploying? If you're here in Netlify, just use the defaults. I didn't actually change any of those build settings. I just hit build, right? So you actually shouldn't need to change them. Just take whatever it asks you for, or whatever it provides by default. How do you move your code from Google Colab to GitHub? That is a great question, and a somewhat complicated one. Yeah, I don't know if I can give a really concise answer here. One thing we can do is sometimes with our notebook, we can say file and then say save a copy in GitHub. And that will allow us to select a repository that already exists on our GitHub account and save it there, right? So you'll go to GitHub, make a repository. It'll then appear in this drop-down list. I've got a lot of repositories. Then you can select that repository and save this to the repository. So that's probably the easiest way to do it. It's not the most fancy way to do it, but it works here. Just file, save a copy in GitHub. All right. What is the difference between this and what data engineers do? Excellent question. Okay. There's a few common job titles in the data science industry. We have data scientist, data analyst, and data engineer. They're by far the three most common. However, there are many others as well. There's business intelligence analyst, machine learning engineer, others, right? Data engineers don't emphasize quite as much the machine learning side of things. I think a machine learning engineer would be capable to fit a machine learning model if they needed to. but their overall goal is making sure the data is of high quality and can flow easily through this kind of crisp DM type process, right? From the database to the data scientist, and after it's cleaned, have like an automated and repeatable method for cleaning the data. Sometimes we say that what they do is create data pipelines as it kind of flows from step to step and throughout different individuals in the organization. Maybe you're working on a team on this project and you're not the only one who needs access to the data. And once you've cleaned the data, everyone needs access to the clean data, not just you, right? And so there's a lot of logistics there. I would say data engineers also work on making sure that our machine learning models are scalable. So they're often versed in things like AWS and different hosting services so that a lot of people can get predictions out of our model without our server crashing and being able to scale things up, right? Imagine you're Amazon.com and all the number of predictions for the recommendations of products they make every day. That model is just buzzing out millions of recommendations a minute, probably, right? And the data engineers are kind of in charge of making sure the model scales up to handle those loads. All right. Any tips on how to master Python? I just started in my class, but I am struggling. Python is a language like any other language. If you're learning Spanish or German or Python, and the thing is that fluency grows over time as you use it. All right, fluency grows over time as you use it. But when you start off on the first day of learning a new language, you don't know all the vocab words, you don't know all the grammar. What do you focus on when you're learning a new language? You focus on, what do I want to be able to do? Okay, today I want to learn the words that will help me go to the grocery store and ask where the bread is or something like that. And you focus on a specific task and then work backwards to the skills with Python or even with data science for that matter that are going to help you achieve that task. That's my recommendation. Don't try and eat a whole elephant. Take it bite by bite and focus on something cool you want to do with Python. Work backwards to, okay, what's the Python I need to know to do that cool thing? You'll be more excited about it that way too. So, but again, I'll share some helpful resources that maybe will help you do some things. Am I able to create front-end websites with Python? Yes and no. The answer here is mostly no. Our web browsers interpret the programming language JavaScript. And so you'll see that in the front-end website that I made, there's actually no Python files in there. There's an HTML file, a CSS file, and a JavaScript file. And that JavaScript is actually using a library called jQuery. All right. So largely no. What we can do is we can have our backend send data to an HTML file and then use a templating engine. Something like Jinja2 is a very common one. Okay. And that can take data that's been served up by Python and display it within HTML. It's probably one of the most common ways that we build apps or web apps using Python. You may have heard of web app frameworks like Django that uses heavily Jinja2 to send that data and put it into the HTML. All right. What is the max depth in the decision tree classifier? Great question here. Let's change it. Let's, just change it and see what happens. So the max depth says to my decision tree classifier, how many nodes or how many decisions are you allowed to go downwards, right? So we looked at, first off, the length, and then the depth, and then the island. So the max depth was 3. We looked at 3 different columns or attributes. If I set the max depth to 4, well, then it's going to look at 4 different columns. Okay. And when I visualize it here, not only do I look at island, but sometimes I will also look at, well, let's see. I don't know what else is being used here. My model might have said, you know what? I'm kind of done when I've done island. There's nothing else to look at, but it could allow an additional decision to be made, and this tree would get deeper, hence max depth. That setting is something we call a hyperparameter. Hyperparameters are basically just settings that we indicate to our machine learning models before they run. And typically, you don't want to have a really big max depth, or else your model will start to kind of memorize the data and do something called overfitting, which is bad. So we tend to keep this max depth a little bit simple. Also, with a small max depth, like we can follow the decision making here, right? It's somewhat interpretable for us as humans to see, what is it that makes a Gen 2 versus a deli versus chin strap penguin, right? And we can really understand our model here because it's not too complicated, and that complexity is limited by that parameter. I've been having a hard time deciding between the two Lambda tracks. Is there a way I can access the videos from the other sessions as well? Yes, absolutely. Maureen told me that one of the best things you can do as you're trying to decide between those two is talk to an enrollment advisor. There is a link in the description of the video to get in touch with our enrollment advisors, and they can talk with you about your specific concerns and interests and help you weigh the options. That's an excellent thing that you can do. Secondly, if you have signed up for any of our free mini boot camps, you should get a link to view all of the recordings sent to you via email. All right. So you should be able to access the videos from the other sessions. As long as you've signed up today, you should get an email that will give you access to all the videos. All right. Awesome. You guys are the best. I love these great questions. I hope you feel like we've done something cool today, even though we kind of speed ran it in just an hour and a half. I hope you understand better what data science is about, what we're trying to accomplish with data here, how we use Python to go about it to a certain degree. We're using other libraries within Python heavily, okay? But at the end of the day, we're trying to do things that are valuable. So if this lesson was valuable to you or not, please let me know. Reach out to me on Twitter. You can link to my Twitter account here's at the very top of the file. I would love to hear from you and get your feedback personally about what you thought about our discussion here, okay? So besides that, thank you for being here. I hope you're excited about data science, and now you've got a good overview of it. Okay. Thank you, everyone. We're going to close up shop now. I really appreciate your participation, and thanks for being here. We'll see you next week